Greetings, everyone. My name is Ahmed Ibrahim. I am a researcher and doctoral candidate working in artificial intelligence, cybersecurity, data science, and digital transformation. Today, I'm presenting my cloud solutions portfolio, demonstrating enterprise-grade AWS cloud architecture through the XYZ University Student Records web application project. This project showcases a multi-tier high availability solution design completed on November 25, 2025. The challenge was clear. The initial architecture relied on a single EC2 instance, hosting both the application and database, creating a critical single point of failure. The system could not handle traffic spikes and required manual maintenance, resulting in downtime. My solution transformed this into an enterprise architecture with a scalable multi-tier design, automated fault tolerance, and zero downtime deployment. Let me show you the transformation. Milestone 1 started with a single-tier architecture costing $23.82 per month, running on a single T2 micro instance with a local database in a single availability zone. Milestone 2 evolved this into a production-ready system. I separated the web and data tiers, implemented a managed RDS multi-as with synchronous replication, added an application load balancer to distribute traffic across 2 availability zones, configured an auto-scaling group to provide elastic capacity from 2 to 6 instances, and enhanced security with private subnets and AWS Secrets Manager. Here's the complete architecture. Users access the application through the Internet Gateway, which resolves to the application load balancer. The load balancer sits in public subnets across 2 availability zones, handling SSL termination and health check. The application tier runs in private subnets with an auto-scaling group, maintaining 2 to 6 EQ instances based on CPU utilization. The database tier uses Amazon RDS MySQL with multi-AS deployments, providing synchronous replication to a standby instance in a secondary availability zone for automatic failover. The security and governance layer includes AWS Secrets Manager for credential rotation, CloudWatch for monitoring, and security groups for network isolation. This design achieves a 99.99% uptime at the time, SLA with near zero RPO and an RTO of less than 2 minutes. The solution leverages multiple AWS services. For networking and security, I configured an Amazon VPC with public and private subnets, security groups as stateful firewalls, an internet gateway for public access, and a NAT gateway for secure outbound traffic. The compute and scaling layer includes EC2 instances in private subnets, an auto-scaling group with 2 to 6 cases, an application load balancer with health checks, and CPU-based target tracking policies. The database layer uses RDS MySQL multi-AS with automated backups, EBS storage, and automatic failover. Security management includes Secrets Manager, CloudWatch monitoring, IAM roles, and encryption both in transit and at rest. Security operates at multiple layers. Network security provides VPC isolation with traffic segregation, a private backend with no direct internet access, and controlled egress via a NAT gateway. Access control implements security group, layering with chained rules from ALB to EC2 to RDS. Strict port restrictions allowing only HTTPS on 443, HTTP on 80, and MySQL on 336, and least privilege principles keeping the database inaccessible. From the public internet, data protection uses AWS Secrets Manager, eliminating the need for hard-coded credentials, SLTLS termination at the load balancer, and manual credential rotation. The high availability design eliminates single points of failure through 4 key strategies. Multi-AS architecture distributes resources across US East 1A and US East 1B with independent failure domains and automatic cross-zone failover. Load balancer resilience performs health checks every 30 seconds, routes traffic only to healthy instances, and automatically removes failed nodes. Database high availability uses RDS multi-As with synchronous replication and automatic failover with 60 to 120-second RTO and zero data loss. Auto-scaling, self-healing automatically detects and terminates unhealthy instances while maintaining the desired capacity across the zone. The auto-scaling configuration maintains a minimum of 2 instances, a desired capacity of 2, and a maximum of 6 instances. The target tracking policy triggers scaling at an average CPU utilization of 50%. This provides cost optimization through a pay-per-use model, automatically scaling down to 2 instances during off-peak hours. Dynamic right-sizing eliminates over-provisioning. Load testing demonstrated scale-out latency under 3 minutes with zero downtime event. The migration methodology involved 3 critical integration points. I updated the application database connection string to point to the new RDs. Cluster endpoint implemented Secrets Manager for programmatic credential retrieval, removing hard-coded passwords, and configured security groups to accept traffic only from the application tier on port 3306. Data persistence verification through comprehensive CRUD testing, confirmed authentication, student record search, create operations, and update operations all passed and persisted correctly. The production deployment is live and healthy at Project ALB 31,977,526. Dial east1.amazons.com. Implemented capabilities include multi-tier architecture with separation of concerns, application load balancer, manager for secure credentials, security groups for layered defense, CloudWatch monitoring for metrics collection, and successful load testing validation. The monthly cost estimate for baseline high availability is approximately $82 based on T2 micro instances in RDS, DBT3. Micro optimization strategies include auto-scaling elasticity, saving 40% versus static provisioning by scaling and during off-peak hours. Instance right-sizing using burstable T2T instances for variable traffic patterns. And managed service O. Red, where RDS handles backups and patching, reducing engineering hours. The ROI delivers a 99.99% availability target versus 95% for single-tier systems with 0 single points of failure, full redundancy, and automatic healing capabilities. This project demonstrates advanced skills in architecture and design, including multi-tier application architecture, high availability across multiple availability zones, scalability patterns, and fault-tolerant system design. Expert level AWS infrastructure services, including VPC configuration, EC2 auto-scaling, application load balancer, REs, multi-AZs, and secrets manager integration. Advanced security and compliance with security group layering, network segmentation, encryption in transit and at rest, and secure secrets management. Let us test the database integration by creating a new student record, then editing and deleting existing records through the web application. This confirms that the application can successfully communicate with the RDS database to perform full CRUD operations on the student's table. Let us test the load balancer by generating high traffic to the students page using the Lotus tool. This confirms that the application load balancer is correctly distributing requests across the web tier and that the application remains available and responsive under load. In conclusion, I successfully transformed a single-tier application into a production-ready, multi-tier architecture, implemented comprehensive high availability across multiple availability zones, optimized costs with auto-scaling performance, and deployed defense in-depth security with Secrets Manager and VPC isolation. Top key achievements include a 99.99% availability target, 100% auto-healing capability, and 0 single points of failure. This demonstrates my ability to design, implement, and optimize enterprise-grade AWS cloud solutions that balance performance, availability, security, and cost-effectiveness. Thank you for your time. I'm happy to answer questions.